Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, I am Midhat Mowla, your A2 Math instructor at Elevare, and today we will be solving P3 Jan 26 paper. So let's get right into it. So for the first question, we are given an equation g of x is equal to 3x minus 5 plus 5 sine x squared. For A, show that g of x is equal to 0 has root alpha in the interval 0.7 and 0.8. Now notice that we are given square brackets, right? So this means that 0.7 and 0.8 are inclusive. So for part A, it's very simple. We just have to input the values of 0.7, and this would give us a negative value, minus 0.55, and then we'll try to find g of 0.8, and that would give us 0.39. So we can see that the sign changed, right? And since we can just look at the equation and we can understand that the function is continuous, so we're gonna write exactly that since sign changed and function is continuous, therefore root lies in 0.7 and 0.8. So let's move on to number B. Show that the equation g of x is equal to 0 can be written in the form x is equal to blah blah blah, whatever. So let's write that down. G of x is equal to 3x minus 5 plus 5 sine x squared, and we are told that g of x is equal to 0. So sine of x squared becomes 5 by 5 minus 3x by 5. So x squared is equal to sine inverse of 1 minus 0.6 x. And sine inverse is the same as arc sine. So x is equal to arc sine 1 minus 0.6 x whole to the power half. Shown. And then for part C, they've given us a formula of iteration. And we are to find the value of x2. We're given the value of x1. We need to find the value of x2. Very simple. x2 is equal to arc sine 1 minus 0.6 times 0.7 to the power half. This gives us 0.7866. And for number 2, find by repeated iteration the value of alpha giving your answer to 4 decimal places. So let's try to find x3. x3 is 0.7458. x4 is 0.7652. x5 is 0.7560. x6 is 0.7603. Zero point 0.7583. Okay, so we have finally found our first reputation. So x11 and x12 are equal to 4 decimal places. So this is going to be our answer. So therefore, x is equal to 0.7589. So we are done with question 1. Easy 6 marks. Moving on to the second question. So we're given an equation and we need to find dy by dx. So y is equal to x squared ln 2x. So I would like to split this into two portions. X squared ln 2 plus x squared ln x. If we differentiate it, dy by dx, 2x ln 2 plus 2x ln x plus x squared by x. So it's 2x ln 2x plus x. Yeah, that's it. For the second portion, it wants us to find f prime of x, another differentiation problem. So f of x is given as e to the power 2x divided by 4x plus 3 whole squared. So f prime of x is equal to 4x plus 3 whole to the power 4, 2 to the power 2x times 4x plus 3 whole squared minus 2 times 4x plus 3 times 4 times e to the power 2x. 2 times 4x plus 3 minus 8 e to the power 2x, 4x plus 3 whole cube, 4x plus 3. We're taking 4x plus 3 common on for the numerator and the denominator, so we can cut these two. The resulting equation looks something like this. Yep. So that's question 2. Another. Wait. Oh, we need to take 2 as common. So it's 2 e to the power 2x times 4x minus 1 divided by 4x plus 3 whole cube. Yes, now it's consistent with the answer that they want. So according to this, a is equal to 4 and b is equal to minus 1. So a is 4, b is equal to minus 1. So that's another 6 marks. Easy. Moving on to number 3. So we just need to integrate this. So this is a very simple integral. We just have to add 1 to the power and then divide it with the added. So the format looks something like this. If f of x is a straight line, and the integral is given something in this format, the differentiation, the integral of this looks something like this: f of x to the power n plus 1 by n plus 1 times 1 by f prime of x. If f of x is a straight line, n plus c. So if we integrate this, it would look something like 3x plus 5 to the power 8 divided by 8 multiplied by 3 plus c. 3x plus 5 to the power 8 divided by 12. Never forget this. Plus c. Extremely important. So for the second portion, we are given another f of x equation. Let's copy it down. Okay, so we need to write f of x down in this form. So we can use 2 methods. The first is long division. I personally hate long division, so I prefer the third line method. And I personally think that it's faster. And if you want, you're free to use long division. Completely your choice. So I'm going to show the third line method. So for the third line method, we know that we need to keep x minus 1 as the denominator. So we need to take x plus 2 common from the numerator. So that's exactly what we're going to do. X minus 1 times x plus 2. We're going to skip a line. It's minus 1 times x plus 2. So if we take x plus 2 common, the first term would be 4x squared. So that 4x squared minus 4x squared multiplied by x would give us 4x cubed. The first term, right? So it's 4x cubed. And if we multiply 4x squared with 2, that gives us 8x squared. So it's going to be plus 8x squared. And now since we added 7x squared, we basically added 7x squared to x squared. So we have to deduct that 7x squared. So now if we need to take x plus 2 as common for this portion, there will be something else here. We need to take minus 7x common here. So minus 7x times x, that's minus 7x squared. And minus 7x multiplied by 2, that's minus 14x. So minus 14x. And as we can see, we have basically deducted 7x. So we need to add those 7x. And the remaining portion is plus 14. And in order to take x plus 2 as common, we need to take plus 7. We need to write plus 7 here. So 7 times x is 7x. 7 times 2 is 14. So that's the third line method. So we have taken x plus 2 common. We can simply cut them down. Now it's 4x squared minus 7x plus 7 divided by x minus 1. We'll repeat the same process. So x minus 1. So the first term will be 4x. 4x. So it's 4x squared minus 4x. So that leaves us with minus 3x to make minus 7x. For minus 3x, we'll have to take minus 3 here. So that would give us minus 3x plus 3. That leaves us with plus 4. And we can't do anything else. So we're just going to write it down, plus 4. And this can be simplified to 4x minus 3 plus 4 divided by x minus 1. So this is consistent with what they asked for. So that's number A of second portion. For number B, we just need to integrate what we found with limits of 9 and 3. 4x minus 3 plus 4 by x minus 1. So this is a very basic integral. So 4x becomes 2x squared minus 3x plus 4 times ln of x minus 1. So that's 9 9s are 81, so it's 162 minus 9 3s are 27 plus 4 times ln of 8 minus, that's 9 2s are 18 minus plus 9 minus 4 ln 2. So it's 162 minus 27 minus 18 plus 9. So that's 126, I believe. 126 plus 4 ln 8 can be written as 12 ln 2 because 4 ln 8 is the same as 4 ln times 2 cubed, which is equal to 12 ln 2. So 12 ln 2 minus 4 ln 2, that gives us 8 ln 2. So that's our answer. And we're done with question 3. Easy 10 marks. Okay, so we're in question number 4. The resting heart rate, H beats per minute, of a particular group of mammals can be modeled by the equation log 10H is equal to 2.4 minus 0.25 log base 10 m, where m kilogram is the mass of the mammal. The mass of one of these mammals is 3 kilograms. According to the model, find the resting heart rate of this mammal. Give your answer to 3 significant figures. So the mass is given. We need to find H. Very simple. Log base 10 H is equal to 2.4 minus 0.25 log base 10 times m. M is 3 for this particular case. So 2.4 can be written as log base 10, 10 to the power 2.4 minus log base 10, 3 to the power 0.25. Or we can just write plus and we can do it 3 to the power minus 0.25. So now we can just remove log 10. So this becomes H is equal to 10 to the power 2.4 times 3 to the power minus 0.25. That gives us 191 to 3 significant figures. Moving on to number B. Show that the equation of the model can be written in the form H is equal to P by M to the power Q. That's what we did over here. So we just have to rewrite it. We can remove log 10 from both sides. So these will be multiplied. 10 to the power 2.4 multiplied by m to the power minus 0.25. So the equation can be written as 10 to the power 2.4. They told us to keep the values within 3 significant figures. 10 to the power 2.4 is the same as 251 approximately. So it's 251 divided by m to the power 0.25. Now notice that they said 3 significant figures were appropriate. So 0.25 is an exact number and it's 2 decimal places, so you can keep it as it is. So we are done with number B. Moving on to number C. With the reference to the model, interpret the value of the constant P. So for part C, they're asking us to interpret the value for the constant P. So it's this value. So this is what we are going to write. It's the resting heart rate for a mammal of mass 1 kilograms. So we're done with number 4. Moving on to number 5. So here we're given a function, and we need to find f of x, and we need to express it as a single fraction in its simplest form. So f of x is equal to 2x plus 16 divided by x minus 4. So f of x will be equal to 2 times f of x, so that's going to be 2x plus 16 divided by x minus 4 plus 16 divided by 2x plus 16 by x minus 4 minus 4. Let's multiply x minus 4 throughout the numerator and the denominator. So that's going to be 4x plus 32 plus 16 times x minus 4. Same for the numerator. I mean the denominator. So that's f of x. Now we need to find f inverse of 12. So we know that f of x is equal to 2x plus 16 divided by x minus 4. So they're asking us to find f inverse of x is equal to 12. F inverse of 12, right? Which means that this entire thing, the value of y, will be equal to 12. This will be equal to 12. So let's solve this. So there's another method that you can use. You can try to find the inverse of f of x, so f inverse of x, and then you can input the value 12 instead of x for f inverse of x. But that's a lengthy process. Moving on to part C. So g of x is equal to ln x. We need to find the exact values of a such that f of g of a is equal to g of a. Okay. We need to solve this. So we can assume that y is equal to ln a to make it more simple. middle term. So ln of A is equal to 8 or minus 2. So A is equal to e to the power 8 or e to the power minus 2. So that's part C. And we're done with the question. So moving on to question number 6. Okay, so this is a trigonometric equation. Okay. So we have an equation and we need to express it or write it in this form. So let's do that. 2 cos theta minus 60. We know that cos A plus B is equal to cos A cos B minus sin A sin B. So let's use that. So cos of minus 60 is equal to cos of 60, and that is equal to half. It's going to be cos theta minus sine minus 60 is equal to minus root 3 by 2. So it's plus root 3 sine theta. So and we can rationalize this. So we have shown that it can be written in this form. So moving on to number B. Okay. So let's copy the equation first. Now we can notice some similarities between this equation, the one that was given on A, and this equation. If we assume like 2x minus 70, this can be written in the form 2x minus 10 minus 60. So if we assume that 2x minus 10 is some variable theta or z or anything, any variable, then this equation can be written as this equation. It's the same equation. So assuming theta is equal to 2x minus 10, this can be written as 2 cos theta minus 60 is equal to 3 times sine theta. So tan theta, and this can be written as tan theta is equal to 1 by 6, 3 plus root 3. So theta is equal to, but we also have a range of value, right? X is less than or equal to, it's less than 180, greater than or equal to 0. So x is less than 180, greater than or equal to 0. So theta is going to be less than 2 times 180 is 360. 360 minus 10 is 350. So 350. And greater than or equal to, when x is equal to 0, theta is equal to minus 10. So it's going to be minus 10. So we need to find the values of theta within this range. So let me just calculate this. Okay, so theta is equal to 38.3 or 218.3. So the theta is equal to 2x plus 2x minus 10. So x is equal to 48.3 divided by 2 is 24.15. So it's 24.2 and 114.2 degrees. So that's your answer for part B. And we're done with this question as well. So let's move on. So question number 7 shows us the figure shows a sketch of part of the graph with equation y is equal to 4x, where f of x is equal to absolute value of 3x minus 11 minus 4. The vertex of the graph is at the point P as shown in the diagram. So this is the vertex. State the coordinate of P. So for A, the equation is f of x is equal to magnitude of 3x minus 11 minus 4. Since it's the lowest point would only occur when 3x minus 11 is equal to 0. So 3x minus 11 is equal to 0, or x is equal to 11 by 3. And accordingly, y would be equal to 0 minus 4, so that's minus 4. So moving on to number B. Solve the equation of x is equal to 8. So if you draw a line, you'll notice that there are 2 points. So I need to find the coordinates of both points, the values of x for both points. So first, let's assume that 3x minus 11, this is going to be positive. It's equal to 8. And for the second equation, it's going to be negative. So we have found the corresponding values of x. So we're done with number B. Oh, this was B. Moving on to part C. Okay, so for part C, the line L has equation y is equal to mx, where m is a constant. Given that L intersects the graph of y is equal to f of x at exactly 1 point, find the possible values of m. So there are multiple ways a line can intersect this graph exactly once. So let me show you. If it just touches the vertex, the line only touches or intersects the graph at exactly 1 point. Or if the line is parallel to this line, this portion of the graph, then it also intersects the graph exactly once. Or if the gradient is higher than that, it's larger than that, up to infinite, it again intersects the graph exactly once. Because no matter how I draw the line, like if it's parallel, let's say that these two lines, they're parallel, right? So they intersect the graph exactly once. Even if I draw a line over here or here or here, they all intersect the graph exactly once. Even if I go the other way around, like if the gradient is negative, it still intersects the graph exactly once until the line is parallel to this particular line. That's the limit. This is the limit. So we need to find the gradient of this line, and we can just directly find it since it's positive, and this is the equation. So the gradient is 3. For this line, the gradient is 3. So for y is equal to mx, gradient would have to be greater than 3. For this line, the gradient is negative 3. So gradient has to be greater than minus 3. And for this line, the gradient would be 11 minus 4 minus 0 divided by 11 by 3 minus 0, which is equal to minus 12 by 11. So these are the set of values of m, possible values of m, for which y is equal to mx. Process the graph exactly once. So this is part C. Moving on to part D. The graph with the equation y is equal to fx is transformed onto the graph with equation y is equal to a times f of x minus b, where a and b are constants. Given that the vertex of the graph with equation y is equal to a times f x minus b is 5, 16, find the values of a and b. Very simple. 5, 16. So it's 5, 16. Initially, it was 11 by 3, minus 4. 11 by 3, minus 4. And y is equal to a times f of x minus b. Y is equal to a times f of x minus b. What we're going to do is, for a, since the value of y is being multiplied, we just have to find a is basically 16 minus divided by minus 4, because a is the value that minus 4 is being multiplied with to get 16. So this would be minus 4. And for b, it's basically going to be the shift. So x minus b means that this value, if we add this value to b, we get this. So b plus 11 by 3 would give us 5. So b is equal to 5 minus 11 by 3, which is 4 by 3. So that's the answer for part D. A is equal to minus 4 and b is equal to 4 by 3. Now again, let me explain this part again. Y is equal to a times f x minus b. From this equation, we can understand that the y value, it's being multiplied with a, right? So we are multiplying the initial value of y for the vertex, that's minus 4. We are multiplying this with a to get this value, 16. So that's how we get the value of a. So a is equal to minus 4. And as for b, the graph itself, it's shifting to the right by b units, right? And we can see that 11 by 3, we are adding something to 11 by 3 to make it 5. So 11 by 3, we are adding b units to get 5. So b will be equal to 5 minus 11 by 3, which is 4 by 3, which is exactly what we did. So moving on, we're done with question number 7. Easy question. Easy 10 marks. Moving on to number 8. So x is equal to e to the power 2 tan y. Ln x, we're going to take ln on both sides. 2 tan y. And tan y is basically equal to ln x by 2. So now we can differentiate this bit. If we differentiate this entire equation, it becomes 1 by x is equal to 2 times sec square y times dy by dx. And we know that tan squared theta plus 1 is equal to sec squared theta. So this becomes 1 by x multiplied by half multiplied by 1 by 1 plus. Tan square y is basically ln x by 2 whole squared, which is equal to dy by dx. So dy by dx can be written as 1 by x times 2 plus ln x whole squared by 2. So we're going to multiply the numerator and the denominator with 2, which will give us 2 by x times 4 plus ln of x whole squared. And this is consistent with the format that they gave us. So a is equal to 2, b is equal to 4, and n is also equal to 2. So moving on to question number 9. Okay, so for number 9a, we have this equation, and we need to write it in the form of p plus r sine 2x plus alpha. So let's first copy the equation. Let's simplify this. And previously, we already know that sine 2x is equal to 2 sine x cos x, and cos 2x can be written as 1 minus 2 sine square x. So we can write this as 8, not 8, 5 plus 3 by 2 sine 2x plus 3 cos 2x. And now we need to use this p plus r sine 2x plus alpha. So these two equations are the exact same, they're identical. So we can say that p is equal to 5, r cos alpha is equal to 3 by 2, r sine alpha is equal to 3. So tan alpha is equal to 3 divided by 3 by 2, which is equal to 2. So alpha will be equal to 63.4 degrees. That's it. They asked us to find alpha in radians. So I'll have to use radians. So that's 1.107. And accordingly, r squared is equal to 3 squared plus 3 by 2 whole squared, which gives us 45 by 4. So therefore r is equal to 3 by 2 root 5. So therefore, h of x is equal to 5 plus 3 by 2 root 5 into sine of 2x plus 1.107. So that's part A. Moving on to part B. Figure 2 is a sketch of the curve with equation y is equal to h of x. State the range of h. So that's going to be pretty simple because we know that sine of 2x plus 1.107, the range of this particular part is the only part that varies. So the range for this part is 1 and minus 1, from 1 to minus 1, within 1 and minus 1, inclusive. So h of x is less than or equal to the maximum value, which is going to occur when sine of 2x plus 1.107 is going to be equal to 1. So it's 5 plus 3 by 2 root 5. And it's going to be greater than or equal to the minimum value, which is going to occur when the value of sine theta is going to be minus 1. So 5 minus 3 by 2 root 5. So that's our range. Moving on to number C. The point M shown in figure 2 is the minimum point, okay, on the curve with the largest x coordinate. Find the x coordinate of M. Okay, we are given a range of values of alpha, and we also have the range of values of x. X is less than or equal to 2 pi, greater than or equal to 0. And we need to find the greatest value of x such that the value is a minimum. So at the minimum value, we don't need to differentiate, we don't need to use calculus at all. So at the minimum, we know that the value of this thing, it's going to be minus 1. So 2x plus 1.107 is going to be equal to sine inverse of minus 1. And this is going to be equal to since it's the maximum value, it's going to be 2 pi minus pi by 2. Or it could be 4 pi minus pi by 2. So let's see. Yeah, since it's the second cycle, like this is going to be the first cycle, this is the second cycle, I think it's going to be this one, 4 pi minus pi by 2. But let's see. It could also be 6 pi minus pi by 2. Let's try to find all these values and see which one is within the range. So x is going to be equal to this value, minus 1.107 divided by 2. So let's calculate the values of x directly. So the first value is 1.803. The next value is quite large. It's 4.944. And the final value is 8.09 or 8.086. So the range of values of x is from 0 to 2 pi. 2 pi is approximately 6.28. So this one is out of range. We have these two values within the range, but we need to find the greatest values of the value of x. Therefore, x is equal to 4.94 radians. So this is the answer. And we're done with number 8. Moving on. Oh, we're done with number 9. Excellent. Easy 9 marks. Okay, the final question, I believe. So, two populations of insects are being studied over the same period of time. The number of insects NA in population A T years after the start of the study is modeled by the equation. The equation is given. So T is the time in years. N is the number of insects. Perfect. Find the rate of growth in the number of insects in population A exactly 5 years after the start of the study. Okay, so we need to find dNA by dt. dNA by dt. We need to differentiate this. That would give us 180 e to the power 0.2t. So after 5 years, it's going to be 180 e to the power 0.2 times 5, which is 180e. So you can keep it at this, or you could convert it into actual values. I would like to keep it in this format because they didn't specify what format we need to keep it in. So I'm just going to keep it simple. Moving on to number B. The number of insects NB in population B T years after the start of the study is modeled by the equation NB is equal to 8,000 plus P e to the power kt. And these values P and K are positive constants. Given that there are 10,000 insects in population B at the start of the study, that means the value of P is 2,000. There are 11,570 insects in population B exactly 4 years after the start of the study. There are the same number of insects in population A and population B after T years. Find, according to the models, the exact value of P and the value of K to 3 decimal places. So, right off the bat, we can say that P is equal to 2,000. Why? Because initially, there are 10,000 insects, and initially the value of T is 0. So NB is equal to 8,000 plus P times e to the power K times 0. This is equal to 10,000. And e to the power K times 0 is equal to e to the power 0, which is equal to 1. So this entire thing becomes 1. So P is equal to 10,000 minus 8,000, which is equal to 2,000. And after 4 years, we have the number of insects after 4 years. So 11,570 is equal to 8,000 plus 2,000 times e to the power k into 4. Or e to the power 4k is equal to 3,570 divided by 200. And we can introduce ln on both sides. And we can find the value of k. So k is going to be 0.145. And that's our answer. It's 3 decimal places. Yep. 0.145 and p is equal to 2,000. And as for the final bit, the value of t giving your answer to one decimal place. So after t years, the population of A and B are equal. So it's quite simple actually. I'm just gonna head over to the next page. So 8,000 plus 2,000 e to the power 0.145 into t is equal to 8,000 plus 900 e to the power 0.2t. Or 20 e to the power 0.145t is equal to 9 e to the power 0.2t. Or 20 by 9 is equal to e to the power 0.055t. Now we can just introduce ln. So ln of 20 by 9 is equal to 0.055t. Therefore, t is equal to, that's 14.5. So 14.5 years. So that's it. We are done with question 10. And hence we are done with the entire paper. I hope this was helpful. So see you guys in the next video.